test, 1, 2, 3, 1, 2, 3. Test, 1, 2, 3, 1, 2, 3. Test, 1, 2, 3, 1, 2, 3. All right. So is audio okay? So today we will code the final and up scroller. Looks like this. We have a few things left to do. Oh, I should post the link as well into our group chat. And also, of course, should the boost design Slack. Oh my. Right, I think we're set. So let's start by downloading the graphics. So we have two screens of credits, and this first screen is one font, and then we have the second screen. I don't know. Okay, here is the first and second screens. So there are two separate fonts. We have the ending sprites. Let's see. I'll show it off in window. So we need to convert those into screens and charsets. That won't be a problem at all. See the size of this. 600 high. $75. Second one, also 75. Let's see here what we get. So Mr. Oliver obviously gave me some crap palettes. This is good. Oh. Some Something is wrong with my tooling. There's something wrong with this screen. Some transparent pixel at 14.12. Yeah, it's... I don't know. Let's just convert them. Pick the right one. Suppose it's the same with this one. Be so slow. It's amazing. Anyway, it converted fine. We got 244 unique shards in the first shard set and 253 in the second one. Now we need to byte boost them into a chunk that we load. Now we should convert the sprites as well. We need a sprite sheet. And the name of that file was what? This one. We have, sorry, like 1, 2, 3, 4 sprites wide. Yeah, 4 by 2. And they are high-res. So we only have one common color. And we choose the sprite colors here. The serif bit means high-res sprite. There we go, the first row of sprites, all E. Then we have only one empty sprite and 3 more. So 7 sprites in total. There we go. Whoops. Could have not part to accept the ending. The end sprite stop PNG. What can be the problem? advanced exception 8. Oh, 7 by 4. What? It's 4 by 2. That explains. Yep, there we go. And now finally we need to compress them into a chunk that we can actually load into the game. We have the shore set and we have the screen data. Let's just verify that file. It's the correct size, 3000. Yep. And then we have the sprites. Okay, so now we have all the data we need. Hey Skyhawk, nice to meet you. So is the audio okay? So now we have the compressed file for this, for the double shore sets and the screen data and the sprites. What did we get? 3267 bytes. That's nothing. Perfect. Okay, so we have all the data. So this is the main entry point once the cartridge has started. I will just jump directly into the ending. And here's the ending. And I don't want to spoil everything for you, so I just skip past most of the ending. Otherwise, it's not so nice for you. So just skip here, and I'll skip right to the final screen. So let's check how that looks. Thus begins a legend. So this should be the start of the up scroller, as you can see in this GIF animation. So let's kill the scroller. That's one of the most boring things you can do, but it's essential. So I'll just kill that one. And scroller. Bam. So we need to clear the color RAM, of course, and we need to decompress the graphics we had. So we need to have a new segment with the end. What was the name? Ending credits, or what was it? Ending credits. We have ending credits graphics, which is 2 files. This compressed byte boost file, and then we actually have another file called ink, and this file has predefined labels that tells me exactly where in the decompressed data my stuff is. So I have the char set at offset 0, I have the first screen here at offset 1952, second char set at this offset, second screen there, and the sprites there, which is kind of nice to have all prepared here for us. So we just, this is very easy. Let's see here. Let's scroll there. So we have the end scroller, and we need to decompress the ending credits graphics. It will reside in this bank at these offsets, and we decompress that to free RAM. So the linker will decompress it to somewhere called free RAM. Then we just need to copy the stuff to some nice places. So the char sets, yeah, well, we'll see about that, but at least the sprites should be in big sprites, and the source will be free RAM ending plus this one, and the size will be that one. So we have the sprites in the correct place. Now let's take a look at the memory map for my general VIC bank. We have VIC sprites at C1000. We need a screen and we need a font, so we have the VIC screen and the VIC font. That's fine, but we need a second one. I think we should have all this in a separate bank actually, not use my global common banks. Okay, let's define some memory for that. Just close these ones. We need some, where should we put it? Ending screen 1. Yeah, it's 5000 is okay. This data is, yeah, exactly, so like that, something like that. Ending font 1 at there, perhaps 6000, and ending sprites at 6800. So yeah, let's put it there. And we need to define a new screen mode that switches to that bank. Yeah, okay, let's do it. Screen mode and scroller. We have an init vector and a tear down vector, and then we have one raster split at the top, like that. We have the init routine. Does nothing. Teardown does nothing. And the raster split at the top should probably set the bank. I have some macros for that, can't remember it. Blah blah blah. Should be something in here. There it is. Oh, this out. Should have some more macros for that. Alright. So we have the ending screen 1. Oh, font first. Font 1. Screen 1. There we go. Nothing more. And we need to switch to that video mode. Using this code. Okay, so just to make sure it runs, just like ink 020. Let's just see if it works. Of course, I need to actually assign a bank in the cartridge for that data. I might have can fit it into that bank, perhaps not. Nope. Maybe 3C or even 3B, perhaps. Nope. 3C. 3C is full. Ah, of course. 3D. There we go. Okay. So that didn't work. It should ink the background. Ah, I didn't set the correct screen mode. Select that screen mode. Oh, that crashed. I really suck at this. Yeah, this top here is actually an interrupt. So I should jump to exit RQ. So there we go. Well, there you can see the split at 20. That's okay. Let's set the channel registers here. I think that's okay. text. Yeah. So let's copy the fonts to their correct destination. What was the name? Name font 1. Sprites. Test again. Cheers. Yeah, we're good. So let's just copy the first top of the screen. First 1000 bytes of that screen. Will this blend? Nope. Yeah, we should of course set the bank as well. There we go. To scroll it, we can double buffer between these two banks. Not sure if we need that, but maybe. Code like this is so damn boring to code. Anyway, I don't. So these screen modes and the arrow cube must reside in RAM because of reasons. But I don't want to waste too much RAM, so I will just, from this interrupt here, jump far into ROM to handle the rest of the scrolling. So I'll actually have the rest here in ROM. Save the current RAM segment and I switch into the ending segment and implement this in ROM. And then I'll switch back here. So now the interrupt is handled by the ROM. So I don't waste RAM. I'd rather waste ROM instead of RAM. So let's implement a scroller here. Here we can have local RAM variables wherever we like. We can have an ending or this BSS segment. some local variables. Here, local variables there. Yeah, well, I suppose we should just copy stuff. First of all, we should have a split at the bottom, like at F8. And then we need to copy the screen. So we have can't really decide how I want to implement this. I will see. Maybe I should just do a dump scroller and then I don't know. Maybe I should do everything in the main code. So see that this works. Yeah. So we have fine scroll here. And that we can't do because we're in a ROM segment, so okay, obviously this has to be in RAM. I can't have self-mod code in ROM. So we just have to copy one screen to the other. Just let the IRQ scroll. And that's what we have to do. So this is a main loop, so let's just mem copy from mem copy is kind of slow, so let's not mem copy. Let's just copy here. want to scroll up, so something like that. And that will produce crap on the final. Let's do this instead. Then we won't actually overwrite anything. And we will overwrite some sprites. That we will do. So we'll have to handle the final bit like this. Our post fence error. Well, is that right? Maybe. That should be okay. So now we create the second buffer, and here we will need to buffer swap. Yeah, something like that. Shouldn't do anything right now. Oh. awesome. Well, indentation or not, that really doesn't help because it doesn't work. So, well, should kind of scroll now, but well, not yet. So we have the wrong, well, the correct screen. The second screen is just crap. Why is that? Shouldn't be. Why is that so crappy? I don't understand. Let's just fill it with FFs. That's not correct. I suppose I'm too tired for this kind of coding right now. This is... Here's one arrow, for instance. Okay. Well, there are a lot of errors, so that was one quite severe. Okay. I still obviously can't code. So I wonder, what's this? I suppose a second view will help. So let's try this again. Yep, that's okay. Oh. So I have 1 frame error here, which means that the mutex should be set 1 frame later. Right here. How hard can this be? This is ridiculous. So I'm actually scrolling into the same buffer. Obviously. Yeah, I am. So when I have buffer 0, I show the screen 1. Otherwise I show screen 2. And when I show screen 1, I copy from 1 to screen 2. That should be invisible. Should be right, but of course I can try that. Should make a difference. It's weird. It's super weird. Anyway, let's just assume that's okay. I want to close the screen. No, not close the screen. Crop the borders. Like so. Yay, I made a scroller. Now we need to copy the new data in. And let's just find our pointers here. So we have this pointer. I suppose we should take the final line there, like so. That should be okay. And now we just need to copy that final line. So we should actually only scroll 24 lines here. So it should be 192 here. And then we have to just copy the last line from source screen to the final line here, which is something like that. And the same goes for here. Each time we wait for the mutex, we can increase the source pointer. And now we actually also need to place those screens back to back in memory. They're not like that now, we have to change the makefile here. So let's put the screens back to back like that. I don't understand why this is so slow. Okay, so we add the source pointers. Like that. It's probably wrong, but let's just test it. Okay, that was okay. So now when this first screen has scrolled past, there we have to have a char set split in the middle of the screen here, because there is a second char set for the lower half. So we need to have a dynamic split there. But first I have to go to the loop. Be right back. Okay. Let's see here. Okay, so we need to have that dynamic split. Where is it here? We don't need to have this in the BSS segment. It's just a waste of bytes actually. Let's just put it right in RAM. Reserved as is. Now we have to have some kind of split. Let's just add a split. Just copy this code, I suppose. Let's just add a split in the middle of the screen, just a random split for now. Now nothing works. Amazing. Now I have two splits, so I have to have a 2 there. So we have the random split in the middle. And everything is dead slow. And why is that? That's because we can't have a split at that position. So there we go. I don't really like this actually. Because everything comes 1 frame too late and it's super annoying. And then we change this buffer 0, which is kind of wrong. So let's just add a bottom split as well. Just to have it kind of neat and tidy. Not exactly optimal, but that's not our aim at the moment. So you see this exit IRQ quick, that will exit IRQ without polling keyboards and mouse, but we have to do 1 for keyboard and mouse just to be able to exit from the ending. So perfect. So now we just have to now everything is kind of nice and neat and tidy. We can just actually implement this ink buffer mutex when we do the switch now, because we do everything in order. Like this. And now it scrolls way too fast. Yeah, sorry. Like that. is still off by 1. This is insanely stupid. Then we're back to what we had. We have to do that check in the top, I suppose. Yep. We have to. This is kinda annoying. We really have to increase the mutix here. So if we want to do it once, then we have to adjust everything else to support this. Which means that all this should be handled in the top. So let's have the correct buffer values. And we have that here. Feel really stupid now. More beer helps. So we're at the bottom. And then yeah, it's a fine scroll. That's a problem. That is a problem. Now the buffers are in order across the previous bar. Yep, that's okay. Now we just have to place that split properly. No, actually bottom is the same as top, so everything could be in top actually. place the bottom code here. Just do TXA. Perfect. Tjena Frantic. Tack för att du tittar på min filkod. Okay. So let's place that split dynamically. We need a frame counter, I suppose. So that split should be valid from, I don't know. I don't know. We need to scroll. We have. Do we have how many characters did we have? 600. That's 75 characters. I don't know. Let's just do something. So you have to wait a few frames. We have to wait. We have to wait. How much do we have to wait? 25 minus 24. We have to wait 51 by 8 frames. Okay, that can be correct. Okay. That's like 8 seconds. Yeah, maybe. Let's just wait 408. Okay. So let's just put the split at like F8 to start, so we don't see it. Okay. It actually scrolls too fast. We have to scroll half speed later on, but let's do that later. Cheers. So we need to wait 408 frames. You could also do a 16-bit split Y position and clamp it, so if it's outside of like 10 or F8, just clamp it to F8 or 10. That's another possibility. That's actually quite clean. So let's do a split pause, which should be like visible screen is 38 plus. I don't know, something like that. Okay. So at the top here we need to calculate the actual split pause and set the initial buffer correct. If it's buffer 1 or buffer 2. This is like one line of C code. So let's check if it's, let's bound the values first. So let's check for the upper bound. So if we do like, if it's, let's subtract the split pause with the first visible char line. So usually it's a greater value. Yeah, okay. Let's subtract that one. Yes, let's do that. Store it somewhere. Actually, we have an IRQ temp for that. Let's check this. Let's not do anything stupid here. Yep. So if I've never used TextMate Frantic, I don't know why I use Sublime. It's just a text editor really. It doesn't really help me. I could use Notepad as well. So we need to clamp the upper bound. So if this value is positive, then if it's positive, we should just show this stuff. But if it's negative, yeah, we should handle the lower bound before, but let's do that later. And if it's negative, then we're actually shown the second font immediately, like so. Okay, but we need to clamp the lower bound as well, because that's what actually sets a split position. So maximum split position would be like F8. This is hairy code. Damn, this is hairy. We don't need that value actually. I'm lucky we have so soothing music so that the brain gets in the correct mindset. And we don't need that value either, I think. So, okay. We have the maximum minus the split position, so usually it's negative, and if it's negative we need to clamp to F8, otherwise we use the value calculated. And also if it's clamped up, we really shouldn't do the split at all. Which means number of splits should be dynamic as well. This can only go south actually. So if we have if this is negative, we don't have any splits. The same goes with this. So in the standard case, we have no splits. But we might have one split here. Like so. And we have to clamp the upper bound, so if the split passes outside the screen, this value will become positive. No, negative if it's outside. So if it's positive, we have splits, otherwise it's just can exit RQ. However, if we have a split position here, it should be stored to that value, this here. So split pos. Like so. Yeah, so this is split pos actually, straight up. Like so. And it will start on like 38 plus 400. Hairy stuff. Okay, so we have just one split in the normal case, and in that normal case we just exit RQ just to see that it works. Yep. Regarding the sale of this cartridge, that's a tricky question, because I don't have the rights to sell it. Actually, I actually got an explicit no to sell it, so that means I can't sell it, or I should say we can't sell it. So what we will do is that we will release the cart for free as a digital download. We will release the whole source as open source. But what you can buy is a box that's painted by Archmage, which doesn't have any formal copyright infringements on it. No text like Eye of the Beholder or anything, no Advanced Dungeons and Dragons or anything. It's just a box. And you can also buy a custom cart from us, which is my hardware design, which is also will also be open sourced, my hardware design. And what you actually buy is the box, which is our own, no copyrights there, and the service to pre-populate that cart with the open source game, so that you can buy. So it's a gray zone really, but that's what we'll do, and I'll produce 1,000 units, and there will be a pre-order page. So this is our way to get around these problems. Actually, Wizards of the Coast have a open game license we could use. The game is almost compatible with that, but we would have to remove like the beholder name, we would have to remove the fireball spell, and we would have to remove some of the enemies and rename them. And that would be quite crappy, but it can be done. So yeah, we'll see. But you can buy a box and a service to pre-populate a cart with my own hardware design. I can burn any game you like actually, but I will default burn Eye of the Beholder unless you state anything else. Any Easy Flash game. Not sure if you guys have seen the hardware. I actually have it right here. So this is, yeah, don't mind the patch cables there and the resistor. Those are not in the final design, that's just a design mistake from my part. So this is a hardware that the game runs on. So it's an Easy Flash 1, almost compatible. This card is cost reduced, so it doesn't have any SRAM. There's a JTAG port there, and this is a Tag Connect port actually that doesn't require any mating connectors. Really nice. It's like super nice. Let me show it. Let me show you this stuff. I have it right here. Somewhere in my messy laboratory. No, that was not the right one. Here is the Tag Connect header. Okay, so here it is. I can't find it. Never mind, I can't find it. Anyway, so this is Tag Connect header, and that one actually programs this CPLD. And once that's programmed, I insert the cart into programming mode and currently let the C64 flash this one using EasyProg with a special driver. But I'm currently planning to do a custom hardware that can flash this chip from a USB SD card. Yeah, so that's my baby steps in hardware design. It was a fun thing to learn. Anyway, let's continue with the scroller. We have the wrong buffer showing. And why is that? This is the wrong buffer. It should be showing buffer 0. So we should exit here because the split pass is way out of visible range. But no, we didn't. So why is that? Well, split position way out of range. And we subtract line F8 with that value, so it should become really negative. Should be negative now. What have I missed? It's a wrong bank, definitely, but I mean, the clamping code here will set the bank, and I mean, I could just change some stuff here and it will work, but it really shouldn't go beyond this point right now, because the split pass is like a very large value, definitely larger than F8. And if I subtract F8 with a very large value, it should become negative. So it should exit here, but it doesn't, so I missed something stupid. It's something really stupid. The border should flash. Oh, okay, I have an exit RQ here. Sorry about that. Now the exit, now the border should flash. Yep, perfect. Still the wrong bank though. That's because we don't set a default bank. So we really need to have a top bank here. So this is like initial state, only one split, and we show the current font. If we are in the upper bound, this is we only have to handle the negative state here. Yeah, exactly. Clamp lower bound and we're done. But if we have an upper bound, we have to handle only the negative state. This one we already have done. So we just set 2 splits there. But if it's negative, we're still on 1 split, but we have a split somewhere. Okay. Something like that. Perfect. Now let's actually activate the split by decreasing the split pause every frame. Something like that. There goes the split. Obviously something is wrong, but we get the idea. It's kind of good. Let's show the split a bit better. Like so. Here comes the split, and it's way too early. It should be like way down. So I did something wrong here with my calcs. I guess I should so the first screen is 75 characters high. That's 400. It should actually be just 75. Just plus 600, of course. There we go. We could just adjust that split position a bit, like 580 or so. But it's still wrong. It's almost right. So there's a split and good margin. So we have some problem with the buffer code. this one here, it's a split here. No, it's not. It's the initial state. So if this is negative, we're actually on font 2. No, font 1, otherwise we're on font 2. That's this state here. Yep, that's correct. How hard can this be? So this is like the state when we don't have a split, but we're on the second buffer. Right after it, when this is scrolled to the top, it should start flashing. Yeah, it does, but on every second frame actually. So why is that? Okay. So it only passes this code every second buffer. Just have to double check this. So only here every second buffer. Yep, only every second buffer. Why is that? Can't have anything to do with split pos. So it must mean, yeah, this one. Of course. This is default initial state. So there we go. Now we're good. Okay. Yay, we made a scroller. So let's take a look what should happen here. So it should scroll really slow and the sprites should scroll up very slowly. And they should match. Okay. Should stop right in the middle. So we need to have some scroll speed. It's like this is like every second frame and the end is every fourth frame or so. So this is like every second frame. This really sucks. Let's just have a frame counter instead. Yeah, maybe even slower. It's very slow. It's very slow, you're right. You are absolutely right. I really can't code like this either. This will not be right. We need to do this stuff anyway. This has to be done each frame, obviously. Like so. Something like that. Should be every fourth frame now. So it's too slow. So every second frame. Yeah. And the sprites will move every fourth frame. Okay, let's place the sprites then every Hey Oliver, yeah, just had to code them someday, right? So why not live code them? So every fourth frame we should move sprites, like so. And we should have the sprite pause. Let's just put them somewhere, like there. We have to clamp those values. Hey Andreas. Do sprites. It's actually easier to have live coding because you have to speak. Can I explain what you're doing? That's like rubber duck. What's it called? You know, when you speak to a rubber duck to explain a problem, and they find the solution. So let's place the sprites. We have 7 sprites in some weird configuration, like this. And by the way, guys, this is Oliver's delivery to me. It's kind of awesome because you get everything served on a silver plate, which is nice. So I have to set the sprite colors. Like so. And we have to place the sprites. Place the sprites. Yes. $112 plus 24. So this is like sprite 1, 2, 3, 4, 5, 6, 7. So sprite 1, 2, 3, 4. So this guy is the second one. And this sucks. Okay, 112 plus 24 for the first guy. The second sprite is like 1, 2, 3. And this guy is like 1, 2, 3. And the 8th sprite, we don't really care about that one. Yeah. Yeah. Is that right? I don't know. Maybe. Maybe, baby. And we need to enable like the 7 of the sprites. They should all be right here, and they should be in a single color, and they should be unexpanded Y and in X, and they should be above characters like so. I got this rule for remembering all these registers, so like if it ends with a B, it's a background priority. If it ends with a C, it's like color. If it ends with a D, it's a double in Y. And D is 10, you know, it's just after the position, so it's a high X position. And then there's only one left, which is a Y position, Y stretch. So just remember B for background and C for color, and then you're good. Then I always tend to invert the bits for background priority, so. Anyway, we need to place the sprites. So we have the sprite position. Let's just place them at 80 for the moment. And our do sprites, just place the sprites. Like so. So we place the first one. And these guys. Then we need to go down for the remaining 3. Like so. Do we have the ending? Yep. But I forgot to set the sprite pointers. And sprite pointer should be quite simple because it's just like TXA, STA, ending screen 1 plus 3f8.x, and screen 2. Yeah. something like that. No. CLC, ADC. Like so. There we go. The end. And now that little guy should scroll. So we just have some sprite position, and we should like clamp that one as well. So each time we scroll it, we should move it. Like so. And then we should clamp it. So let's do a clamp for upper bound. Or lower bound. Clamp lower bound. That can never actually happen because you should stop mid-screen. So we just have to clamp upper bound. So sprite pos +1 SBC F8 plus like 30 or so. That's a bottom border. And if that value is negative, we have visible sprites. I think. We have a very large number subtracted by the border. If it's negative, we have visible sprites. Yeah, we have. Otherwise, we don't. Like so. So we should actually not set DO15 here. So the sprites should be visible right now. I failed. 80, oh, it's negative now. Yeah, then it should be visible. Low value, high value. There we go. Good night, Frantic. So let's put the sprites outside the screen and sync it. So like 300 or I don't know, 600 something maybe. No, that way off, like 400. You can actually see the sprites in the top before, so the clamping has to be done a bit smarter. Not plus 30 because they are already sprite positions. So like that. see how this looks. We can fulfill Oliver's idea. No. So we need to plus it with like 100 pixels or so. Maybe actually 600. Oh, 500 then. Are we good, Oliver? Was it good? I think it was good. Just need some padding. We need some padding. Yes, we need padding. Give me padding. We need padding. We need padding. Where is it? Like this destination? Filled with zeros, and we have like 75 times 2 times 40 plus some padding. Just need to clear that stuff first. But that will overwrite the fonts, the sprites. No, this is free RAM, of course. No, it's okay. But it will overwrite. It will overwrite the. Let's see here. So the sources are first on the screen. So we have to have the sprites before that. It doesn't really matter, we could copy the sprites first before we wipe that data, so we can do like this, and then we're good. Yeah, that should do it. Or not. Yeah, of course. Like so. Now wait a minute, I can't wipe that data. I must clear after sources screen too. Like so. So now we have a 10 extra lines, so clear the data. It should give us space enough. Then we should like stop there. Okay. We should read the fading code. I had that already. Show thus begins a legend. We have this fading code already. It's this code here. So we can just wipe this. And we'll do the fade. Only the fade. So we do that before doing anything else. We should do that here. I think this should actually fade in that code. And we need to switch the screen mode, but we shouldn't scroll. We need to have a variable for that. Like so, and will it fade or will it not? It will not. Okay, why didn't it fade? Why doesn't it fade? Screen mode is set. We should actually have cleared the 800. We don't actually call do scroll now, so yeah, that doesn't matter. We have the upper bound clamp. Will set the correct fonts. No, it will not. Actually. Okay, let's just do simple. DH11 has to be set anyway. So let's just have some default values here. That will the override. Like so. That failed. This should be easy. I am really suck at this. What is this? How can this even be a problem? Just set the font. This is so weird. Okay. And if I don't do that? Okay, I destroyed something. Yeah. Did that work? Yes. But it fails desperately once our call show thus begins a legend. Which means that that code is crap. And destroys something. How can I do that? It's just a simple failure. How can this be a problem? It's just a fade. Yeah, because this starts scrolling. I don't really do watch pointers and stuff like that. I maybe should someday. It's about the scrolling here. It's about the initial state. There's nothing here getting overwritten, it's just me who doesn't keep track of the states. It's something else. I actually do have a quite fancy code here, because if I have a running vice like so, just go to the shell and enter monitor like this. Now I'm in the monitor. I can just like oops, jam. Yeah, I feel too much, but anyway, you get the idea. The problem here is just me doing just quick and dirty coding here without actually thinking. That's why why there is a problem. I don't even know where to begin to check. The easiest would be to just take over the screen mode for the fading. Let's see here. That's also a hack. So where the top, if there, let's just do this instead. So if we have a scroller, we should do fun stuff here. Otherwise, we should just set the default state. Like so. And also the number of splits should be 1 at default. Also, we should see it fade. I suppose I don't dip back to the correct position. Nothing. If I don't do the fade. Nothing. Yeah, for the default set I have to set DH11 as well. And that's like something like that. Because the screen is turned off default. So there we go. And then we should fade it. I think that fade code actually fades on the wrong lines. Yeah, it's like 11 or so. Maybe not. Just fill a bigger area. Still black. Should call it also. the correct row now? Maybe, baby. Oh yeah. There we go. And then we should start to scrolling. Now I have to fix all the other issues. Whatever that is. Yeah. I have to really fill with once actually. And then yeah, that I don't think it will flash. It did, unfortunately. So we need to clear the screen. Maybe. No. Reverse the charsets. Yeah, I don't know. Then I have to fade using a split. I don't think that's easier, to be honest. Yeah, I see what you mean. Yeah, that would be easier. But now that part works. Just have to set the initial state here. Yeah, well, this weight here, we can't do weight there. We should wait here instead, so that we can have everything filled initially. No, it's not a problem. I could inverse those character sets, but I mean it works now, so let's not do that. I'll just have to do the end checking and fade out of the sprites, or fade out of the characters. And now I really should have. Yeah, it would be wise to inverse the character sets. Actually, you're totally correct. You are totally correct. Should we do that? Yeah, we should. Let's do that. Will we get any other problems with that? No. I don't think so, actually. Let's do that. Just for the sake of it. Just for the sake of it. What about the sprites in the background text? Yeah, that's... oh yeah. So when we fade out the sprites, the sprite priorities should be below the text. Like this. And that will not work with inverted character sets. Thank you for that. Sorry, Smasher. Your idea will not work. Thank you, Andreas. I'm too tired. Okay, so let's just fade it out. It's just one line of text to fade out anyways. So we need to find the stop condition and just fade it out. So let's just find the stop. Scrolling. Like so. Done. There's a do scroll. And we don't don't need to have a done variable, we can just use the start scroll variable. Let's compare her. No, not that one. It is split boss, sorry. And we have to have some value here, like, I don't know, like 30 perhaps. Let me just stop it. And here we check for the end condition. And here we should fade out. Not there. We need to go further down, probably some negative number, like -100 or so. I could have an analytical approach to this and actually sit down with pen and paper and calculate all the positions, but I don't know, I just want to get it done. What's the problem now? Also, we should check the high byte first because that's more efficient. Doesn't really matter. To go a bit more. Like -400. Close. 390. There is something wrong with the buffers as well, and that's obviously because we have this kind of lame way to handle this. I mean, we really should do bound checks and everything. Why can't I just do that, actually? That should work. Like I did initially. Do all this code. Can't see where that should work. I have to set the 011, but that should work. This should work. Yeah. Exactly. Now are we done? Did we hit the sweet spot? Oliver, should we scroll further? This is good. 2 more pixels? Maybe 2 more pixels. Yeah, let's do 2 more pixels. There we go. Then we just need to fade out the sucker. Are we done? Are we done? Are we done? Oh, look at that. That's good. So let's fade out. Fade out. Fade, fade, fade. Let's just reverse the fade in. And also the sprite priority register, I'll set that in the init, I hope, and not each frame. No, it's just in the init. Yeah, I think fade-in works. Let me double check that. Thank you. Maybe because of the warp mode, yeah. Let's double check that. Oh, you were absolutely right. What did I do? How can that... Why did that stop working? Maybe I'm on the wrong line. Let's just take a few more lines to just check. Hey, Ptong. No, the fading has definitely stopped working. Good spotting. Damn, it's kind of embarrassing, isn't it? I mean, how hard can it be? So let's just hide everything. So we are there, we clear the screen in that area. I suppose we just hit the wrong spot. Let's not start a scroller, just fade in the sucker. Pitch black. Ah, it's the initial DO11, of course. No, it's nothing wrong with the fade code. It's me being lame again. The 011 is cleared default, so we have no scrolling. Just have to set it to a default value. Yeah, we always have to set it to a default value. So just do that in the init code, like so. Then we replicate this code for the fade out. There we go. There's a fade. Let's see if we hit the correct spot in the fade out. It will fade in again, but let's just see if it alters the correct line. Nope, it did not. So we need to have Mr. Oliver's fade table. So it's D3 E4 B 8 and 0. Is that correct? That's an 8, right? Let's just double check that color. That's a 9. And the dark gray is a B 4 E 3. I could have one more step here with 5 or A in between if you like. There is one luminance here that you could have. But okay, let's do it like this. And we need to hit the right values here, so let's just see here. Damn it. Okay. So where doesn't it end? Start scroll is 0. So it should be white and then switch to black when it stops. Doesn't. Why? WC stops. Yeah, the weight, it doesn't reach the weight mutics because we don't scroll anymore. Yeah, okay. Of course. I had a hunch that this would happen. That's because we're in this buffer here. This is so ugly. This is so ugly. But ugly is good, I just want to wrap it up. I don't care with this code, to be honest. Let's see if we hit the right character lines. Not sure, maybe. Nope. I suppose we're further up. I should enter the monitor and just check. But that's too easy. Let's just waste everybody's time by scrolling it over and over again. Damn it. There we go. And then if it's E, the sprite should be switched to the foreground. I take that literally. If it's E, I switch to foreground. Ooh, this will not work. It's in the init code, it will work, it will work. Close but no cigar. Oops. Bit too many anonymous labels. That always becomes a mess. Are we good? Oliver, is this good? Are we done? Is this finished? So shall we try it with the full intro or exit? Let's see here. Okay, please repeat. Now watch closely. Okay, just warp speed a bit. Okay. Is it good? Awesome. So let's try the whole exit. So okay, spoiler alert now. Close your eyes if you don't want to see this. Just need to make sure it works with everything else. So this is a full ending. This has never been shown to the public before. Albeit with the wrong music. Ah, there's a bug. I'll fix that some other day. Yay! And let's see how much space we have left on the cart. Thus begins a language, I should say longer. Okay. Before we scroll, you mean? So how long? Like a second? 1 second pause. Let's see. Let's see how that looks. I think we could do like shake hands. There was a bug there. We should fix that while we're at it. Yeah, there's a split bug there. Let's fix that. Reset hand sprites, shake hands, set screen mode. It's this screen mode here. Everything is NTSC compatible. This is not yeah, okay, the pauses are kind of wrong, but all the IRQ timings are NTSC compatible, and green and old NTSC. Actually, so I suppose it's the first split here. That's off. No, it's the second split. It's like split 2. This one maybe. There we go. That has to be checked on NTSC as well. That could very well break on some other platform. Oh, what's the name? Old NTSC. Let's just check. It's good. Let's check new. And let's check green. Yeah, looks good. So we have this. Now that glitch after the handshake is just because we've done some skipping. I don't think that will be there in the flick above the text. I don't think that will be show. I don't think. Let's see. If you run it from the beginning, I don't think you will see those bugs. You can move the split point to a bit more stable state, like transition high priest, so that we clear the screen more properly. There. Okay, the text was shown there. Okay. Yeah, obviously because we set all the lines for that. Should only set the 23 lines. Okay, still a mode switch bug. Fix that by maybe like that. Actually, we need to clear everything, but we should do it prior to switching the graphics mode. So let's just set these ones here. Yeah, let's just set it here, like so. Okay. Are we good? I think we're good. We have a superfluous DO20 somewhere. Yeah, it's this one. We don't have to do this. Yeah, great. So let's try the whole ending again. Blah 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 blah. Yeah, very good. Time to wrap it up. Okay, time to hit the sack now. Get to sleep now. Thanks guys. Ending scroller finished. That wasn't so hard. Okay, good night guys.